Well, hi, and welcome to my shop here on December 11th. And it's a bit of a happier day in here now that this radio appears to be working okay. That's about as far as I'll go with that. I did overcome the very annoying problem, which turned out to be a problem with the circuit trace under the board, solved by just resoldering the entire circuit board trace work underneath. So great, that's great. Boy, was I ever fooled by that. But the radio's not done with me yet, so let's see. I've fixed the stuck tuning, solved the problem, taking an extra long time to do it with the board. I've tested the tubes. So I know the status of 3 of these tubes, but 2 of them I'm not so sure. I'm gonna want to retest them again. So what I'm up against now is low output on FM, low volume. AM seems pretty good, but FM not so good. So why is that exactly? Of course, I don't know at this point. But I think one clear possibility is I still have a weak tube up here. So the original tube was weak. This one is not exactly a muscle-bound tube either. So right at the start, this FM amplifier tube could be weak. That could be the reason for it. So I'm hesitant to try aligning this radio, although I'm concerned its alignment is off, and maybe a little bit of tweaking, even if I have to study up on some German, might produce a big result. So how can I figure this out without messing up the radio in the first place? Find out where the local oscillator is running in the radio. Now, how can I do that? Pretty easy. Local oscillator signals are usually floating around the radio. All I got to do is take another radio and pick it up. I can pick up the local oscillator, which should be running at 10.7 above, maybe below, but above. I already know it's above the target frequency. So the radio, FM radio, is tuned to 100 exactly. So that should put, if the IF frequency is 10.7 for FM, that should put a signal at 110.7. So I'm going to flip over to the SDR now. We're going to take a look. Oh, I should show you this though. So the SDR antenna is simply this clip lead clipped together. This is just going up to the antenna input up here on the radio. And I've just thrown it here because I believe the local oscillator is available here somewhere like that. Okay, so now we'll look at the SDR and see what we can see. So obviously you see this white line here and this little peak here. Nothing else. We expected this to be at 110.7 and we're at 111.8 or something like that. Quite a ways off, I think. 111.8. Is that really the local oscillator? So I'll tune the radio. I'll make sure I'm tuning the FM part of the radio. I will tune it up frequency, so this thing should go up also. And there it goes. So if we use 10.7, then if we set this to 110.7, gotta go down, up, where'd it go? I tuned too quickly, it disappears. I think this is okay right here. The radio is tuned on the dial at 100. So we really expect this peak to be at 10.7, which is just off here a little bit. Let me move that over. Hey, we're at 2 here now. The weirdness in these SDRs sometimes. So I'm expecting something right around here. How do we get 2 up here now? Now let's see. I'm going to tune, in order to sort out which of those is the real one, I'm going to tune the radio up in frequency and see which one moves up. Oh, only one's moving. Okay, so the one that's moving is the local oscillator. What exactly that other thing is, I don't know. Some signal in my shop here, I guess. So what this is telling me is it looks like the alignment is off, because when the radio is tuned to 100 and you'd expect the local oscillator to be at 110.7, it's at 111.8. So 110, 111, that's 1 megahertz. Oh, I think that's significant. In 1 megahertz off. Well, what it may show though is not just that the front of the radio doesn't show you the correct thing. What I mean by that is what you're reading on the dial is not what you're tuned to right now. You're only tuned a little ways out. How true is that? How true is this assessment? I'm going to get a 100 megahertz signal going in here because I have one. I have one right here. Get the 100 megahertz going. It's pretty powerful. Just on these wires here, that'll be enough. We should hear it on the radio. So it shows up. Okay. It's there. So the tone we're hearing, I'll put it at 1000 hertz. So there's a station right near where we are. So let me put this on 100. Now I can change the output frequency of my generator, but not very far. Far enough though. So we can say now that that generator is putting out a signal which appears at 100 on here. Now I need another FM radio, see where it appears on another FM radio. I happen to have one. Let's go up, and over this way. Here it is. It's actually set to 100 right now. I must have been doing this last time. I don't hear it. Let's tune. I think maybe we're below. Oh, here it comes. So I can't, this isn't a, you know, start at 101. That's roughly a megahertz. That's roughly the distance out of the speak, Jim, speak. That's equivalent to the amount the local oscillator's out. So it's all adding up here. Let me turn off the radio. So what we're discovered is on this radio, when you tune the dial to 100, you're actually tuning in 101, which is over here. The difficulty with this is not so much it's wrong on the dial, it's that other tunable circuits that should be tracking along as you tune the radio are probably tracking along in a different spot. So you've got the local oscillator trying to make the radio tune a certain frequency while the rest of the tuned circuits are actually tuned somewhere else. And the result of that is weak output, weak output. This is what I'm trying to get to. So that's an encouragement to go ahead and fiddle with the alignment. The local oscillator appears off. Maybe if I just correct the local oscillator. Now, the pointer's in here. Is the pointer in the right spot on the string? So this upper one, the AM one here, is has been bunged up with a bunch of glue. Somebody glued it right in there. The lower one doesn't appear to have glue on it. I have no reason to think it's shifted in some way. Let's tune the radio to its extremities here. See what we got. It's definitely end of the run here. That's right on the edge of the dial. Move this way. Now, this edge of the dial is really hard to see. There, you can see a little point right above my finger in the window, right near the end, but not quite at the end. That is like a triangle pointing downwards right there. That symbol doesn't appear anywhere else on here. Except, you know what? It appears right there on this band, and right there, and it appears there and there. So, and another one appears here. So these are alignment marks. These are definitely alignment marks. So there's a good chance this one, it's the same everywhere, is the end of the line for the pointer. You know, it's virtually right on the money. How about this upper pointer? What's it doing? Same thing, I bet. It's right on there. Yeah. So these are pointer alignments, and then these other ones are frequency alignment spots. There's nothing in the FM except this pointer thing. I find that a little surprising. Okay, alignment. So AM appears to be okay. FM appears weak. The benefit is in getting the FM stronger. The local oscillator appears to be off. Moving the local oscillator to its correct location may align the radio sufficiently to bring back the FM stronger. Should experiment with that. That means I got to figure out which one of these alignment guys up here, probably up in here, is the oscillator. Shifting the oscillator it shouldn't really be too difficult. I mean, it shouldn't be hard to do. Doing the rest of the alignment's more difficult because you have these resonant circuits that have to be operating, you know, properly. And in the course of doing the alignment, hooking up equipment, you can make those circuits operate improperly, and you end up with an improper alignment. FM, it's all really hairy. But oscillator adjustment, I think I can do. Especially because I can see it on the SDR. Okay, that's good. So what I'm going to do is I'm going to read up on the adjusting the oscillator, practice up my German, and make an attempt at it. So it had slipped my mind. I've left one tired old capacitor in here, and the capacitor I've left in at this point, mistakenly, is this one, 116.05 on this line. This line looks suspiciously like an ABC line. Up to the diodes. I don't know what that is. Is that a gimmick? Gimmick is a small capacitor formed by just twisting a couple wires together. That's what that looks like. It would be worth a couple of picofarads or something like that. Well, so if this is a 0.05 ABC capacitor past this resistor, so it's controlling the ABC speed, if you like, on this side of this resistor. If this guy doesn't have any capacity, then the ABC voltage will, I think you could end up with oscillations, all kinds of stuff going on. If it was really bad. If can this result in low volume? So a strong signal generates a negative voltage which comes back through here, a negative small voltage, 5 or 10 or 15 volts. If somehow that voltage was dragged down by this, so instead of minus 15, you've got, the radio would be loud. I think it would go the other way, it would become loud. So I'm not sure this can cause a problem of the sort we're having with low volume. But it should be changed, definitely. Okay, and what else? What else? That's right. I'm reading all this stuff here. Let's look at this together just briefly. This is the second page of sort of, or I guess it's the right side of the page. showing some of the adjustments here. That's right, yeah. Even these, right up here, these are all adjustments, right up on the antenna. There's some adjustments behind the switches. Now, what I want to find is which one is a local oscillator. Why have they showed these here? Not even sure what this is. Look like cards with contacts at the bottom that you would fit in. I have the feeling these are inside the IF cans. These are the IF cans. These are the insides of the IF cans. That's what this is. Okay, stringing diagram, transformer stuff, part of a board. Look at the other side here. Here we are. I'm going to study this for a minute. There's the other side of the transformers. There's the board, and there's the capacitor there. C116 says right on it. That's the AVC capacitor. I still haven't changed. So we look down through here. Get in trouble pretty quick. I'm looking for key numbers. Lots of instructions here with specific frequencies being given. 555, 515, 1480. That's probably where one of those marks are. 240 ohm, 86.7. Do something to maximum. Do something here to maximum. Yikes. Hey, look at that. 10.7. Did I miss the other frequency of the... It's funny, I thought I saw it earlier when I glanced at this. It's 460, not 455. There it is right there, 460. And 10.7. So we know that 10.7 is not running properly. That's a pretty vague statement. Look at all these instructions here. 4.5 ohms, 12k ohms. Here we are. Increase mid frequency modulator, HF spawning, 10.7. Off maximum. Get it maximum. Whoa, what are all these numbers? So the 10.7 here is in brackets, and it tells me what they're saying is, by the way, the thing I'm talking about involves this amount. So what are they talking about? They're not talking about this amount, they're talking about aligning those transformers. Aligning the IF transformers. 1, 2, 3, 4. Wow, how come so many? Well, tell me which one it is that changes the oscillator frequency. Surely there's a statement of adjustment for that. For UKW and HF. Well, here it's talking about FM frequencies. Okay, so does it give a... Oh my gosh. Yeah. What are you supposed to do in a situation like this? Turn every little adjustment until one of them makes the local oscillator move. That sounds like a foolish way to do it. So what I decided to try is to basically give up on trying to read the German there and sort things out that way, and to take a more direct approach. So there's quite a number of adjustments here. I'm going to adjust each one just a little bit and see if we don't see the local oscillator move. Now, is that for sure the local oscillator on there? I don't want to make a mistake. No, it is not. Ready to make a mistake. So we need this down around 100. That's the problem here. Oh, another problem. It took away the pickup. Okay, let's try that now. There it is. So it just popped up on the screen there at around 111,750. So the radio is tuned precisely on 100 here. So it should be 110.7. 110.7. I'll put this red line on 110.7. This is where we want to push the local oscillator down to here, from here, by turning the right control without knowing which one it is. So we're going to start with this one. These might all be stuck in place too. Oh, it's way down there. Very carefully. I'm just trying to engage. So if the local oscillator moves around, you'll see the line below starts wiggling. Like if I were to do this, see the line is wiggling below? Actually the local oscillator is going up and down too. So this is definitely an oscillator adjustment. Well, and am I getting it? I don't think I'm moving the slug at all. What is down there? Way down there. What is it? I cannot see what it is. Is it a slot? I think it's a very, very fine screw, metal screw slot. Very fine slot. I can't imagine that this won't. Putting in a metal tool like this, it's got to affect this for sure. Let's try it out. I just drop it in there. Watch the local oscillator. Didn't move. It moves a little wee bit there. Now, the screwdriver is no good for this purpose. Felt like I moved something that time. Yikes! Let's just do a sensitivity study here. Just shove the screwdriver. Oh, look at that one. Oh, that one moves it quite a bit. Whoa! Look at that guy go. Adjusting the wrong thing. Not doing anything. It was this one, wasn't it? You can hear the radio is tuning in my signal generator, which is still running. See, I'm retuning the radio. You know what? That's perfect. That screwdriver has to stay in here now for good. That's exactly what we want. Well, no, the local oscillator should be way down to 10.7. What's happening? So this isn't at 100 anymore. So we'll set this to 100. What I believe is 100. Okay, so now we know which one is going to make a big change. We also know using a metal screwdriver is going to throw it way off. What we don't know is which way to move it. We'll find that out soon. Even this is moving it around. Now, can I turn this thing? Oh, look at it go. Look at it go. Okay, down, down, down to... Now, for some reason, it's disappeared on the SDR, but you can tell it's in the right spot now. So I don't know exactly why it disappeared. Okay, now, does this whole radio come back to life on FM because of this? Leave the SDR sitting there. We're on 100. Lots of volume. But I'm probably sending a whopper of a signal in here. Let's get off it. quiet up here. If they tune in this way, it doesn't find the station. Tune the other way. What in the heck is that? It's much better though, isn't it? Let's go down here. We'll pass the signal generator. That's super powerful. Tune it this way, the radio goes quiet. Tune the other way. What the heck is that? I've never seen this happen in the radio. Let's go all the way down here. Oh yeah, okay. There, it's distorted. That's signals at wow. Well, the radios come back to life after doing that. I don't want to be a girl either. So I usually listen to 91.5. It's definitely not 91.5. Can't listen for too long or I'll get a copyright hit. What happened to that big bad religious station here? Let me turn off the signal generator. The one that just jumped out here. That sounds nice. Now, up here where I live, we tend to listen to stations down here, but in the city of Toronto, where this radio is probably going to go, it's this end that you tend to listen to. So you really quiet it down here. So on the volume level, oh, that's not bad at all. That's all it took, I think, was moving that local oscillator. I don't know if I would want to touch any of these other adjustments at all. The volume's down now, so. Hey, that's great. That's great. Okay, so what we've done here is we've removed all the deficiencies out of this radio, and it's actually good to go at this point. AM, shortwave, alignment, all of it is a little nerve-wracking for me. Let's just go for a little shortwave trip here and see what we can find on shortwave. And just moving the antenna to an outdoor antenna now. That's full volume, so that's not. Ooh, ooh. What was that? What is that? What is that? What's all that static? Don't start up again. Oh, you bugger. No, don't do this. So at this time of day, oh, I have to go through a switch. So let's see if we can find anything here. Oh yeah, loads of stuff. I didn't even have to put the antenna on this. $13 be the European. Nothing there. Tricky to tune this radio again. Tiny knob movements make a big difference.
Continúa diciendo Francisco al Magro Domínguez que está escrito.
Well, it's picking up lots of stuff on shortwave, lots of noise. It's working quite well. Nothing down here. We should start up in here this time of day. Not bad considering I actually don't have the antenna switched on. That's not bad. Okay, I think I might have reached the end of the road here with this radio. This might be it. Anything more may just degrade it now. Fantastic. It's got to go back in the cabinet. We got to hear it and see it. Great. Not a lot of radios look this nice. Look at this. It just looks beautiful. Great cabinet. Didn't do any polishing on the cabinet at all. Just cleaned the glass up here a little bit when the chassis was out. Isn't that beautiful? That's why I was so anxious to get this radio working. Speaking of which, why don't we give it a try? Here she goes. Broadcast band. French station. This radio is working very, very well. It's receiving very well.
Now cleared, contains details on Mississauga Road, in Scarborough on the west, and in Mississauga.
Okay, we did shortwave. We'll try FM. I've got to hook up the FM antenna again here. Tangled up. Can't say I've ever had that happen before. So tangled up, you can't untangle it. Jeez. Holy smokes. Okay, got it. Okay, and the FM antenna I've got going in my shop here, it's just this simple rabbit ear arrangement. Now, connect this fairly easily. I can still sneak in here. Normally they would go into these terminals. There is no internal antenna in this radio. This radio, to use it on FM, it needs an external antenna. No doubt about it. Okay. FM.
in Simcoe County, including Portage View and Barrie, Bear Creek Secondary, Steele Street, Nantier Shores in Innisfil, Banting Memorial in Alliston, and Bradford District High School. Parents in Peterborough have one more chance to switch where their child learns. The Peterborough, Victoria, Northumberland, and Clarington Catholic District School Board is giving parents until January 12th to switch from online to in-school learning and vice versa. The final transition date is set to take place February 2nd. An overnight fire has destroyed a boat.
Weak signals. What happened there? I get oil all over my finger. Where'd that come from? Yikes. Okay, I was bumping this antenna here. So what's happened here is I didn't really get it connected.
We hope to have 12,000 daily cases by the increasing hospitalized.
What's this all about now? What's happening?
And has been
Another bad connection in here. In this radio. Right at the last minute. You're gonna come and do this? Jeepers creepers, what just happened?
through. It's announced today for some 12,000 businesses throughout the county to faster, more reliable internet service. Communities like Edgar.
Something wrong with my clip lead? No, don't put something wrong with it. Let's just try a regular piece of wire on here, maybe a couple. Just see if that, if I can pop this right in here. 1/2. And we need the other half. Very basic dipole antenna here. Where's the sound? Oh my gosh, what's happened now? Son of a gun. Where's the stick? Here it is. Give me the stick. Can't believe it. Eliminate a few things here. Well, I gotta take the whole thing out of the cabinet again and work more on it. Oh my gosh.